All right, back just as anticipated. Okay, so we had a job. Okay, so getting back to our presentation, but I may
have
have
to
to wait
wait
a
a
bit
bit.
till everybody gets on.
We have an echo. Echo should be gone now. Do we have any? Can everybody hear me clearly? If you can't hear me, just
Yeah, I'm back on and you something okay.
okay, great. Okay, so if this happens again, this is what we have to do. It just means our video will be split in two. Okay, all right, great. So we were talking about stacking, the importance of minimizing contamination. Okay. The next thing is stringing. Stringing basically refers to laying the pipe usually at the side of the trench in the order in which it will be laid out. So we just lay it along the trench with the joints and what have you that has to be laid. So we're just basically setting it up to make it easy to put it in the trench and connect them and so on and so forth. Okay. So that's all that does. In some instances, we use equipment based on the size of the pipe again. We might use equipment to put the pipes, to lay them down, to string them. In other words, we will also use equipment to put them down into the trench. Now, if we move in all these heavy pieces of equipment, there are safety concerns that arise again. For instance, if it's not done properly, say we have guys in the trench while an excavator is trying to lower a long length of 24-inch pipe into a trench. If something goes bad, maybe it was not tightened properly, it can fall and it can injure the persons in the trench. So all of these things have to be considered as we do work. Okay? Hazards have to be identified and eliminated. We do not want to work under hazardous conditions. Okay, I don't know if you want to share this using the mic, Alphonsus. These stories are
it's
important.
in our little Caribbean or islands. All sorts of things happen during pipe laying sessions. My 16 years in the water utility, I remember there was one occasion we were stringing down the force main from a well that we just commissioned. And apparently the guys were storing the shoes. One of the guys stole theirs overnight and they forgot it. Maybe he bought a new shoes next day, so he left the old shoes in the pipe. And we found out when the pipe was being commissioned. Yes, you disinfect and all of that and so on, but finally that pipe went down and went traveled down a few hundred feet, and not the pipe but the shoes, and went across a bend, a 45-degree bend, and when he blocked the pipe, we realized there was a problem. The pipe was cut. Could you imagine a dirty shoes that used to be white came out very white? So customers drank that over the first couple of weeks. They drank all that dirtiness from the shoes. So it's in lifting your pipe, for example, when you're laying, it's a good practice to always look through. In that case, they were going fast, they were not looking. They were hoping that everything was okay. But the man had his shoes with two dirty socks, as a matter of fact, in there. Just to share.
Yeah, that's a good story. Sometimes other things are left as well as shoes. I remember the guys telling me about a piece of 2x4 that was left in the pipe. And some of the issues that happened as a result, there was a breakage in the pipe. And when they went to do the repair, they found them kind of things in the pipe. Yes, Ezekiel, it means the inspection that should have been done was not done. Because before you commission the pipe, before you actually hand over, you have to inspect the pipe, you have to inspect, that's even before you close off the trench, you have to do your inspections to make sure everything's all right there. Even after you close off the trench, you need to inspect that things will return to a certain level of normalcy. For instance, if it's a road you dug, the asphalt has to be replaced on the road eventually after you've done your testing and you're sure that everything is okay. Asphalt has to be replaced. There are instances where you may have broken in your digging, you damage the pavement, the sidewalk, or you damage other infrastructural things. That has to be taken care of. In one of the presentations for this week, it even looked at grass replacement. Now, we take some of these things for granted because we are in these small islands. And in these small islands, very often, there's nobody to hold you accountable. Accountability is a problem. So nobody says, oh, you don't have people who say, I'm going to sue the utility because the utility came to work on my property and my lawn was nice before they did the work and they did not repair my lawn. You don't have people coming to that in most islands. People don't do that, okay? But in developed countries, people will sue you. And they pay closer attention to these things. So they will inspect and make sure everything is back in order before they actually consider the job complete and move on to something else. Okay? So these are things that we have to pay attention to. These inspections are important because I don't think we want our families drink from that water as well. Ah boy, Alphonsus is telling us that people have started taking the utility to courts. Okay, so that's even more important. Now, listen here. If you were the one on the project and you were the one responsible, you're the one who's supposed to do the inspection, and this happens, say you didn't do something right because you didn't inspect properly, and somebody, a property owner, for instance, takes the utility to court, you know what happens? You stand a chance of losing your job. Because very often, when these things happen, especially if the case becomes public, it becomes a public matter, to save face or to show, right, that we are doing something, the utility might be quick to fire you. So you might be out of a job because of negligence. Okay? And a lot of managers that we have around the place, a lot of managers are not necessarily, what's the word, forgiving. Okay? Because of the magnitude, if the thing becomes a problem of public interest or a high magnitude, the likelihood of you retaining your job might be slim because you would have cost the company money, a lot of money, because the company has to go to court. You would cost time. You would actually affect the reputation and branding of the company. Okay, because I remember in one of it was our first or second class, we looked at something called consumer reports. These consumer reports that the utility has to give annually. Okay, consumer confidence reports, they were, right? If you're doing things like that and things like that come up, the public tends to have less confidence in you. For instance, if the public found out that this shoe was in their drinking water, though your chlorine residual would have taken care of all of the possible biological effects of that dirty shoe being in the water, the psychological effect of knowing that you drank this man's dirty shoe water is grave. Okay? And I don't think most persons would be happy to know that a WASCO or water utility worker had them drink their shoe water, I don't think the public would be happy about that. Even if you would tell them, hey, we are doing monitoring and the water quality is still good. It's the same fear that people have, for instance, even if we were to take, for instance, sewer water and we were to disinfect it to the point that it is the same quality as the drinking water, if persons know that's where it's from, persons are not likely to want to drink that. Okay?
Yeah. The only country that managed that well and managed to reach Singapore.
Yes, yes, Singapore manages that well. Singapore is an interesting country.
It's one of
They have a lot
one
of
in a
nice
million.
systems.
Yeah.
They have a lot of nice systems. They were pretty
And
impressive.
I must say that is an important point you make. When that happened in Grenada in the utility, we had to keep it under wraps. We had to make sure it didn't get out. Nobody got sick because, well, you know, we were superdosing and overdosing chlorine at the time to disinfect the line and all of that. But as I see from an objectionable point of view, and you know, the public find out that, so we had to keep it kind of tight, that occurrence in the utility.
Yeah, that's a serious PR problem. PR would have to do some hard work to reassure the public there, and some jobs might be lost. Oh, okay, easy here. All right, so let me move to the next slide. Okay, so we just looked at transport. So that's, and if you realize in our discussion, we're actually moving ahead. We're not doing it in the order in which it was presented. Okay, so we have discussed things about excavation, trenching. We spent some time discussing the safety for trenching. Okay, but these are the 4 processes that excavation involves. Planning is very, very important. Never underestimate the importance of planning. Planning, a good plan will mean that you're going to go and do the job effectively and efficiently. Okay? If you do not plan, it means you'll be running around like a headless chicken on the job site. Okay? And you can see when there's no plan on a project site. Even the person who's in charge might be giving varying instruction or contrasting instructions. When they tell one person to do this, they forget that's what they said. They tell another person to do something else. It also affects the management of the resources that are available. Okay? It also affects the timeliness in which work will be done, the quality of the work. So planning affects all of these things. So if any repair or installation has to happen, the first thing that must take place is to plan what has to happen. And in our planning, here are a few pointers we want to consider. We want to identify the location. Where is the repair or the installation going to take place? What type of alignment? What grade in terms of the soil slope? What location? And this involves not just operators, but this involves the engineers as well. So the engineers will figure out a lot of this, and the plan is going to sit down to the operator, who will actually be doing a lot of the hands-on work. Okay? So we want to indicate what are the fittings we're going to use, and the fittings will be affected by or informed by the type of pipe. What material is the pipe? What are the ends of the pipes like? Okay, so these are some of the things that will determine what kind of fittings. So before we actually go to the site to start any work, we know all of that already. We should know how much pipe we need, what diameter of pipe we're using, what types of fittings. In most instances, there's some kind of plan or drawing. Okay, there's some kind of drawing, 2-dimensional drawing, scale drawing that shows you what has to be done where. Okay, in some instances, we require the use of surveying equipment before we can do the trench. We can dig the trench. We also want other details on the area. Do other utilities have things in the ground that we are going to excavate? Now that's important. because in some instances, not just telephone, yeah, telephone and telecommunication things, these are important, but there are also things that might be there that might be dangerous. In some countries, people receive fuel, gas for cooking. People receive that through pipes in the soil. So if you're a water utility worker and operator, and let's say you're a supervisor, you're in charge of a unit that's going to work to repair or to install pipe, you should know whether there are gas lines in the soil that you're about to dig. Because if you do the one wrong move can lead to a gas leak. And imagine you have a gas leak and you have a partner on the job site who smokes, he just light up his little cigarette, explosion. Okay, so that's important. Also, in some instances, there are electrical lines that are under the soil, and you don't want to go and break into it. In most instances, when you're excavating, the soil is wet. There are instances where the soil is more than wet, it's waterlogged. Okay, and so if you're going to dig a trench there and you have a break in an electrical line, that can pose problems for not just the operator of the piece of equipment, but for individuals who are on the ground if they are not properly insulated. Okay, so we want to avoid any of these kinds of things. In addition, you do not want to damage the property of another utility, because if you damage it, it means you have to spend money to fix it. And most times you will not be the one determining how much money you spend. The utility is going to do some kind of estimate as to how much it costs to repair the equipment or whatever that's in the soil, how much time it will take, man hours, how much they will have to pay, do we have to bring in experts to do this? So they will create the estimate and your company will have to pay it. Okay? So you don't want to be in that position. So that's why planning is very important. And planning is important for work, for life. Planning, he who plans can better handle the situations that come up and so on, because a facet of planning that takes place, and some of you may eventually go on to do maybe some kind of project management thing if you're a supervisor. A lot of engineers would have that kind of qualification as well. So you would have to plan, but also consider worst case scenarios when you're planning. Consider what can happen as a result of you starting to do this, and have some kind of plan that you could implement, okay, for if it happens. I want to mention emergency plans there, okay, which is something that the utility is supposed to have in mind, emergency plans, and it's something that you should have in mind. And it's something that you should have in mind when you are doing any activity at work. Emergencies are things that happen, and most times they are not things that you can predict, but they happen, and when they happen, you should be ready for them. You should be ready to act. You should have a plan for if it happens so that you can act. Okay. Notification. What is somebody asking about fiber? Or APUA? I'm not familiar with APUA. That's in which island?
There's Antigua. There's the Antigua Public
Antigua.
Utilities Association.
Oh,
and they're asking,
okay.
well, in the case of APUA is kind of unique because you are the umbrella of most of the utilities.
Also, they would have access to everything then.
Yeah, but I know they have a private, I think they have a private cable provider and so on. But the issue is mentioning the fiber optic. But you end up being I don't know if it's the fiber optic of the utility that is under APUA or the private.
Mains.
I know there is one that is private. But you have issues. I mean, to get along that, there is some standards which we have to follow. And that should be on the plans in the first case. You know, the distances between the water and the electricity and the phone, the telephone lines and so on. And you
Mhm.
should adhere to them. What goes on top, what goes below. Even among the
Yeah.
utility itself, whether the sewer go on top, the water go below, and the sewer should be below and the water on top and all of that. So you
Yeah,
have
so
to
they should
try and
have a
stick to that.
standards.
Yeah. And
Yeah.
most of it should be prescribed on the drawings,
Yeah, I agree with that. Okay, but that is a special case, man. I didn't realize Antigua had all the utilities together. Okay, so notification is the second thing. We want to inform property owners adjacent to where we are going to be doing our work. We want to inform the public because the public will be affected in many instances when you're doing work like that. People are not going to have water. Okay. Is that another question, Gary? Just wondering if they would have to pay. Well, since they're under one umbrella, I'm guessing for situations like that, they would have whatever arrangement to take care of the damages. But I think that I would expect a lower likelihood of damages because you're under one umbrella organization. So there should be a
That's
sharing of
better said than
knowledge.
done.
Yeah, wow. Wow. Wow.
But it's a good point
Wow.
you're making, as a person say. What has
Yeah,
happened?
because
Go ahead.
yeah, go ahead. Go ahead,
No, in my
Alfonso.
experience, because I work with them, I did some work with them in November. I did training with them too, and one of the utilities are very close to my heart. We lose our good friend who used to be the manager there a couple 2 years ago, as Ivan Rodriguez. But whether it's good or bad, apparently the electricity part of it tends to want to carry the water all the time. Because they make
Oh
money.
boy.
So
Oh
you have
boy.
to match out whether it's good or bad.
Wow.
I think for them it's good.
Yeah, the major
But
hazard
there's
there,
some drawbacks too.
Yeah, it's a major hazard. Wow. All right. So let's look at some considerations for trenching. In our region, we're not concerned about frost, but I want to remind you that ABC, which is the organization doing the certification, is a US organization. Well, in US and international, but more US, right? And as a consequence, they have to deal with talk about things like frost, the frost line. So when we are trenching, we're concerned about how deep we're going to dig, because in situations where you have frost, you want to make sure the pipe is below the frost line to minimize freezing of the water. Okay. We also want to look at ground conditions. This will be applicable to us, groundwater conditions. Okay. If the soil is, for instance, very soggy, okay, if you have a lot of water in the soil, we want to know that. Because if the soil is very soggy, it means that the soil may not hold as well. And that will inform what type of trench support we are going to use. In some instances, we may have to forego sloping and benching and go straight to either shoring or shielding in some instances. But again, the decision will be made based on inspection by a competent person. The size of the pipes being installed obviously will determine the size of the trench. Economics as well. We have to look at what is most cost effective. Yeah. We don't want to go and dig a big trench that we don't really need, and maybe we hire a backhoe to do it. We're paying per hour, and the backhoe is there digging trench for how many hours, and then we come and it's a much smaller pipe we are putting in the trench. That's a waste of money. Okay, and we want to make sure we're using the best equipment as well to cut down costs. Okay, so economics is a major component of this. We don't generally, well, we don't do things if we don't know how we're paying for it. Yeah. and of course the utility lines. If we are going to excavate and dig a trench, we have to think about that as well. Okay, and there are some challenges in terms of bedding. I don't know. I hope you looked at. There's a link here. Well, that link would have led to the safety video, I think, from what I recall. Okay, so there are some challenges in terms of the ground, in terms of soil conditions, other utilities, and bedding. Okay, bedding is basically what we are laying the pipe on in the trench. Okay, based on the type of pipe material, whether it's going to have traffic on it, and so on, the bedding material might change. But in most instances, we try to avoid material that has rocks and pebbles and like sharp items in it. So we don't usually use things like construction waste. Construction waste has steel, pieces of concrete, stones, sometimes pieces of metal from the framing of the house. Well, that's well, it's not this. Well, we have the steel, the rounded kind of steel, and then we have the steel infrastructure that might be in the concrete. Sometimes we have pieces of this thing in construction waste. So we not go that doesn't come anywhere near our pipe. Okay, for obvious reasons. Then pipe laying. Look, we have inspection again. Okay, jointing. That's where we actually connecting the we're connecting two pipes together, and there are various types of joints that are available. The text highlights only one, but there are various types of joints. It highlights mechanical joints or push-on joints. Okay, but there are various types that are available to us. The mechanical or the push-on ones are very common. Okay, also speaks about thrust restraints. Often when we have in our distribution system, we can have something that we call water hammer. Okay, and some of you may have heard it in your pipes at home. Some of you may not be familiar with the term, but you may have heard it in the pipe at home. You hear a kind of knocking effect in the pipe. Okay, so this can actually damage the pipe in the distribution system. So what we do, we put what we call joint restraints to ensure, yeah, that's right, Gavin, immediate stoppage of water. For instance, if we close a valve too fast on the system, then that could cause water hammer. Because don't forget that the distribution system is a hydraulic system. So we have a fluid that is contained within these pipes. So if we do something in one location, that energy is transferred through the medium, through the water, to other locations. Okay, so things that might seem simple. I guess I just close that. You might have let's close that pipe, man, and you just boom, and then you have that water hammer effect. Okay, great. Thanks, Alphonsus. Okay, so we use thrust blocks. There's a video that looks at that as well in the content. Everything that I'm speaking about there, well, yeah, everything I'm speaking about there, except for things that I highlight, I tell you is not there, is in the content on the site. So as if you have not gone through the content, when you go through, you will see it. So it's available to you. Okay. So don't even fuss about this PowerPoint presentation or anything like that, because the content, if you look here, is just screenshots. Some of them are screenshots from the videos. Okay, in 10 minutes, this thing might stop again. Okay, very important fact here, pointed out by Alphonsus. During water hammer, the pressure could spike up to 10 times the working pressure of the pipe. Okay, so 10 times is a lot, and that could actually lead to damage in the pipe. It could lead to, like at points where the joints, where you have these push-on joints, it could lead to an undermining of the joint so that you develop a leak because the pipe can move as a result of that pressure. So sometimes we use thrust blocks at joints, tees, and other fittings to ensure that the pipe does not move. Now, the first blocks have to be made out of a material that will last. Okay? They have to be made out of a material that can handle the impact of the water hammer. So they absorb the impact of the water hammer so the pipe does not get damaged. Now, we're looking at the utilities pipes, but water hammer could also damage the pipes of consumers. So that's a concern as well. However, the pipes in a consumer's house are not under the purvey of the water utility. So there's not much we can do about that apart from trying to control water hammer so that it does not get to the consumer. Okay, now that's a very important point that, as I mentioned, the fact that we're not in control of our consumers. Alphonsus is bringing a very important point there, that in Grenada, there's an instance where the brick in the pipe actually undermined somebody's house. And Grenada is not the only place, in St. Lucia as well, that has happened. And some of the workers have found themselves, they're trying to figure out where the leak is. And there's a back and forth, and this takes time, okay, which means workers have to be spending time on it. And the longer it takes to sort it out, the more damage to the consumer's property. And so we have some serious considerations here. Yes, the water utility, if you were there for our first class, I believe, we are responsible for providing adequate pressure. And as a consequence, we have to use things like, we want the pressure to be adequate, but we don't want the pressure to be above what the consumer's plumbing can handle. So it's our responsibility to maintain the pressure within a certain amount or below a certain amount. In some instances, well, it varies a bit, but most times pipes in a house are under 100 psi. Most times they weigh under 100. Well, they should be maintained under 100 psi. In some instances, we look at it as 60 or 80 psi. We will look at operating under that. We look at these as maximums. Now, in instances where we're dealing with industrial water supply, most times these industrial guys want about 150 psi or thereabout. Okay, so that's a different scenario. Now, the pipes in the plumbing in our consumers' homes and even the plumbing that's on the distribution system, they have pressure ratings under which they function properly. So if we exceed these pressure ratings, what will happen is breakage and eventually damage to property. Because imagine a pipe receives more pressure than it needs to, and you have a brick in a wall somewhere. A brick in a concrete wall is a headache because it's difficult, one, to tell where the brick may be coming from. The person might see water somewhere else because water takes the easiest path that it can get. So in taking the easiest path, the water could end up anywhere else in the house. And you're looking for it and you're not finding it. So that's a major issue. Alphonsus is giving important information in the chat with regards to opening and closing pipes. Okay, so he's saying a pipe, for example, a valve which closes with 21 turns should be open and closed in 5 minutes. So you should take your time. That's for 8 to 12 diameter. So you should take your time to close it, 5 minutes. Now, sometimes workers behave like they're in a hurry or rush. And as a consequence, they try to do things to get it out of the way. And but being in a rush sometimes, boy, the time that you save there, you are actually going to lose it somewhere else. So I always think it's just best to just, whatever you're doing, make sure it's done properly. make sure it's done up to standard, take the time to do it up to standard, take the time to follow standard procedures. The standard procedures are there for a reason. Take your time to follow them. Because in the end, where you think you're gaining time, you lose so much more time in other places. For instance, you rush to do something, you didn't inspect it, you rush to close the pipe, and then you have water hammer, you get a damage that costs a couple $1,000, and that costs a couple days or weeks in trying to sort it out. First to identify where the problem is, and then to eventually carry out a repair. Okay, so it makes sense to just, there's a protocol, follow the protocol. That's why it's there. Okay, a lot of the standards and protocols that are put in place are put in place because of our past experiences as a society, and as individuals we learn from our experiences. And part of the learning from our experiences is to set standards and protocols in place to prevent certain things from happening. Okay, so, and shortcuts always, yeah, they always come at a price, always, always. Now in some instances the price may not be paid in your time in whatever unit you work in, but a couple years down the road, the utility develops a problem because you may not have done something properly. See, there's another scenario. A 12-inch main house not closed properly. The main broke, where the valve was not closed properly. The main broke in 7 locations. Roads affected, tourists affected, hotels affected. For a simple act, just to take your time, take your little 5 minutes to close your valve. 5 minutes, save 5 minutes or save 5 minutes, and enter a world of pain and headache. Not worth it. With regards to the pressure thing that we discussed, error relief valves are often used when we are doing these major installations, because don't forget, in a lot of instances when you're doing these installations especially, you install a new pipe and a lot of air builds up in the system. Okay, and we need to find a way to let that air out. So sometimes we use hydrants that are the high points of the distribution system. Now the way it works basically, if you fill a bottle of water and you leave a gap from the top of the bottle, the cap, to inside, let's say you leave a 2-inch gap. If you were to turn the bottle around, you will notice that the air moves because the air is lighter than the fluid. The air moves to the highest point. Okay, and that's what happens in the distribution system. Air moves to the highest point in the distribution system. Now, I am not sure, it's 16 past, and this is going to cut off again in less than a minute. Okay. There are a few things that I want to, so I'm going to leave this presentation. It will cut off, but I will restart it. Okay. I hope that you are able to stay with me just to run through. I am going to skip some of what is, I believe, is well covered in the videos. Yeah, and I want to a little bit just to mention a few things about disinfection, and then to mention the SCADA system.